All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning. Today we're going to spend the entire stream learning as much as we can about GDScript because I'm going to be honest here. I've kind of been fighting this mental battle of like being divided between whether I should test out doing VTubing stuff in Godot and testing out a bunch of other things as well, but like really I'm really tempted to test out VTubing stuff in Godot. So I've kind of been like, uh, I haven't been able to make up my mind. I kind of want to carry on the development of my VTubing application in Unity, and I probably will as well. But at the same time, I'm really tempted to test out uh, building this tech in Godot using the various tools that Godot provides. That being said, before I try to make any complex systems, I want to be able to, uh, I want to learn the language itself. I want to learn GDScript, understand all the concepts of GDScript. And we got a good bit into this in the last stream, I believe. I think it was the last stream. Yeah, I think it was in the last stream. We did get quite a bit into this. We were reading the GDScript reference page. We read a bunch of other things as well, GDScript related. And I need to finish. You know what? Let's set a goal. Maybe if I can finish this entire page, which I'm not entirely sure if that's going to happen, because there's a bunch of concepts here, some that I'm already familiar with because I've been a programmer for a while, some that I'm not familiar with, but I think it's more going to be a situation of me familiarizing myself with the workflow of this language, how this language works, the various components that it provides us with, and the syntax. That's kind of what's going to be my challenge right now. So eventually, once I have a better idea of what I'm doing in GDScript, like once I'm able to build, once I have a hang of the language itself, then I can start doing more complex things, because there's a bunch of ideas that I have of things that I want to try out. Multiple things, and I've done research on the components that give you the ability to do these things, which is great. Like Godot does provide you with options to do many of the things that I'm trying to do, and that's kind of why I've been really, like, you know, I'm really tempted to just start testing stuff out in Godot. I was also really excited for Godot Python, but that's going to take some time before it's ready. So for the time being, I want to do as much as I can in GDScript, and then eventually I'll also look at the C# side of things. At some point, like once I've done a fair bit of GDScript stuff, then I can look into the C# side. I know C# already. I've been doing it for a decade. So all I'll need to understand is how C# concepts map to Godot concepts, and if at all there are any workflow differences to keep in mind. And then I can decide if I want to carry on doing stuff in GDScript or in Godot. Not Godot. In GDScript or in C#. Obviously, both of them are going to be in Godot. So, yeah. For the time being, we're gonna be learning GDScript. Well, we're gonna carry on learning GDScript. A couple of things that I want to try out for the time being that I have my eyes on are, first of all, I want to control a rigged mesh from script. So basically, I want to do inverse kinematics, but I don't want to do the math for it myself because that's way too tedious. What I'm looking for is something that can provide me with the tools to where I can just, I don't know, set how do I even say this? Set bone positions and rotations, but I want something like even one step above that, to where I can guide the bone positions and rotations using transforms, and like the calculations are the calculations they get done like in the background. There probably is something like that. I have seen something similar. At the very least, something that lets you mess around with bone position and rotation. I haven't done it myself yet, but yeah, I wanna explore that more. I also want to explore shaders. That's another thing I want to explore in GDScript. No, not in GDScript. In Godot. Shaders is another one. Particle effects is another one that I want to experiment with in Godot, because they have the concept of GPU particles and CPU particles. So I wanna explore both of them and see what I'm able to accomplish with it. Another thing is networking. That's another one I'm interested in. I want to set up, because they provide you with the option to set up a WebSocket server very easily. I want to try setting that up and do some communication between two clients. I want to also set up a simple socket server, a simple UDP socket server, and do communication between two clients. They also provide you with the tools for that. There's a helper class that lets you start up a server. I haven't looked too deep into it, but like from what I understand, there is a helper class that lets you start up a server, or at the very least implement a server. That's another one I want to look into, and I also want to do a bunch of the stuff from scratch. Like I want to implement the entire server myself, using bare bones sockets, which from what I understand, GDScript does provide you with that to a certain extent. I think I don't know what the limitations are there. So I'm gonna have to see how I need to go about doing that whole thing. I need to read up on that. It's using something called, hold on, I have it here. Let's look up UDP. It was something called Packet Peer UDP, I think. Yeah, so there's Packet Peer. There was Packet Peer UDP as well. Yeah, there it is. So there's this. I need to read up on this thing. I need to read up on UDP server itself. I guess I need to read up on Packet Peer as well. I won't be reading up on any of these on stream. This is like for off stream. For the time being, we need to look into. But like this is also one of the reasons why I want to get a hang of the language first. Also, I'm curious to see if let's say I decide to use C#, right? C# has its own networking namespace, its own sockets namespace. So that allows you to do a fair bit of socket related stuff. So I also want to compare the two workflows and see to what extent I'm able to do socket stuff using C# in Godot. And I want to compare how well that workflow works out versus using the structures using the structures and tools that Godot provides for socket stuff. I want to see what the difference is going to be between the two, because I've done a fair bit of socket stuff on the C# side, so I'm very well aware of how to do stuff there. But I want to see if I'm going to be able to apply that in Godot as well. Give me a second. Let me drink some water, and then we can start. Reading this. I'll continue from where I left off, which I don't remember where I left off, but I guess we'll just keep scrolling and see. We'll just keep scrolling and see where I'm able to. How do I say this? We'll keep scrolling and I'll stop at whatever point I think I might have left off at previously. That is if I remember. So yeah, let me drink some water and then we can start. Okay, so I think the other day we were reading up on this stuff here. These are the keywords. I think we did. I scrolled all the way down to look at classes, I think. So I'd kind of like broken up, my workflow, seeing like I was jumping between different topics based on whatever I suddenly got curious about. By the way, speaking of stuff that I'm curious about, I do want to look into how to do async stuff using GDScript. I want to see how GDScript handles async stuff. Okay. Oh, yeah. Okay, so let me just carry on what I was saying about the async thing. One of the reasons for that is because I want to see if, especially when you're doing stuff like networking stuff, unless you are doing async, you are going to be using blocking operations, which, not a good thing, because if you block the main thread, then there's a whole bunch of problems that come along with it. So I want to see how we are meant to handle that in GDScript. I'm sure there's a way to go about it. I just need to find out what that way is, and the best way that I'm going to be able to do that is by just reading this entire thing. Eventually, I do want to get to the await thing, and I think yield as well. I'm not sure. It says it was previously used for coroutines, but now it's kept as a keyword for transition. What does transition entail here? I've seen other people mention transitions here. Using animation tree. Okay, so animation transitions. All right. Cutout animation, method tweener. Method tweener. Wait, they have like a tweening operation that lets you like blend between two methods? Or am I interpolates an abstract value and supplies it to a method called overtime. Method tweener is similar to a combination of callback tweener and property tweener. It calls a method providing an interpolated value as a parameter. See tween.tween method for so and so. Yeah, let's look at the tween class. How do I get to tween? Lightweight object used for general purpose animation via script using tweeners. Oh man. Yeah, I want to look into this as well, because this basically becomes like it allows you to set up something like, for one thing, it can allow you to set up like a lerp kind of operation, like it mentioned, interpolation. But other than just interpolation, well, I mean, okay, technically the other stuff that I was about to mention, which is like they're higher concepts, but they're built on top of concepts like interpolation. So tweening allows you to accomplish stuff like blending and linear interpolation and stuff like that. So yeah, I want to look into this. Maybe not now, maybe later on. Oh yeah, so speaking of stuff that I might look into later on, we can look at so inverse kinematics is something that I feel like there might be some outdated stuff here as well, and I need to be careful of not going into the outdated stuff. Something that I noticed specifically here, so like there's this thing called skeleton IK 3D, right? I read up on this, but then at the end here I noticed deprecated. This class is deprecated and might be removed in a future release. And then I looked at the code here in this demo, or maybe I'd found the information online. I don't remember. Somewhere it was mentioned that there was a separate class that you could use to do this, to do what I was trying to do. Was it skeleton 3D? I'm not sure. A node containing a bone hierarchy used to create a 3D skeletal animation. Skeleton 3D provides an interface for managing a hierarchy of bones, including pose, rest, and animation. See animation. Okay. Okay, so if you are able to set up, if you are able to set the pose using this, technically that means you can achieve inverse kinematics with it, right? What I need to look into is some tool that does, or some node or class that does these calculations for you, because dude, doing proper IK calculations is it's no easy thing. Like I can spend time looking into it and learning all the math behind it and all, but like, dude, that's a whole other thing. I don't want to do that, if I'm being honest. Because like I can do it, I can look into it. It's just that to do it well, to achieve good results, there's a fair bit of math and coding involved there. So like even if I did make my own solution, it would be a pretty jank solution, and it would look like shit. So I wanna try and find a solution that something where someone has already implemented this stuff, or if they've implemented it in Godot itself. Like I haven't seen here. I think it was here, right? This is where I'd seen set bone pose or set bone position and rotation. Yeah, here's a method. Set bone so and so, and then you can specify the position and whatever bone index is supposed to be here. You can set position and rotation and scale. Usually with bone hierarchies, you have I forgot what the connections are called, but like you have this thing. So like when you're setting up the hierarchy, fuck dude, at some point in time, I should go refresh my knowledge of fucking rigging in Blender, because I haven't touched that in such a long time that I don't remember half the shit that I'd learned. And the shit that I learned was a couple of years ago. I'm not even kidding about that. So like you can set up a bone hierarchy. You can set up well, I mean, it's a hierarchy, so you can set up like parent-child relationships between the bones, and you can also set constraints. I don't know if I think you can also set modifiers that do certain things, but I think constraints are part of that. I don't remember exactly, so don't take my word for it. But you can set constraints on the bones, and there are various other settings that you can set which make it so you can do stuff like let's say you move a hand, let's say you move the palm bone, right? You're moving just the or let's say you move the collection of palm bones, because there's like, let's say there's a bunch of bones there, right, for like fingers and stuff. Let's say you move that collection, You also want the forearm to move, the elbow joint to move, um, the bicep area to move. You want all of this stuff to move, and you want the. This is just one example that I'm giving. You want all of these bones to be able to move based on the fact that you are moving that one thing, right? But at the same time, you also don't want the bone structure to fall apart. Like, you don't want the bones to separate. So like when you go way too far and the hand is stretched like way too, it's stretched out straight, you don't want the bone to separate anymore. So it just stops moving at that point. So like these kinds of things, these kind of constraints and stuff, I want to see to what extent they're respected in Godot. And I want to see if there is a way. Actually, yeah, I just got this idea. What if I rig the thing in Blender and make it so? Actually, no, I don't know if the constraints carry over, because like, okay, I can export it as GLTF. I don't remember if GLTF if the GLTF format stores like bone constraint information. It stores a fair bit of information. I'm trying to remember from like back when I had written my own GLTF importer. It stores a fair bit of like animation information as well. But I don't remember in terms of rig hierarchy, what all does it store? But yeah, that would be an interesting experiment. I can set up. Oh, another thing I should look into is whether Godot has this sort of humanoid requirement where it absolutely needs the what do you call the fucking thing, the rig, where it absolutely needs the rig to follow a certain bone hierarchy. Otherwise, it won't be considered humanoid, and then various animations and stuff may not work on it. I'm all this stuff that I'm saying, I don't know if it's going to make too much sense, but like we had these kinds of issues in Unity. Unity does so like in Unity, in order to have the bone hierarchy be considered a humanoid bone hierarchy, it has to follow a specific structure, and they specify that in like in the Unity docs. Unless you are following that structure, your rig is going to be considered generic, and then there are certain limitations between the two. So I need to see how that stuff gets handled here. But yeah, if I'm able to set up something to where I'm able to I'm just thinking, that's why I'm silent. I'm just thinking, I'm getting ideas. But yeah, maybe one of these days I should do a quick refresher course on rigging in Blender, because like I remember a fair bit of the stuff, but like I've also forgotten a lot of the stuff. The basic stuff I still remember, like creating an armature and then weight painting. So like you basically attach. I don't know if attach is the right word, but you set it up so certain bones are able to influence certain vertices in the mesh that they are parented to. In the mesh that the rig is in the mesh that the that the rig is parented to, that the armature is parented to, because like you have to do the parenting thing, and then when I forgot whether you make the armature a child of the mesh or you make the mesh a child of the armature. I think it's the latter. I think you make the mesh a child of the armature, and then when you're doing that, you get the option to do automatic weight painting and a couple of other things as well. It's not just automatic weight painting. There's a couple of other options as well. But like if you do choose automatic weight painting, it's gonna It's going to paint weights based on it's got its own way of figuring out like where the bones are and like the closest vertices to those bones. It's gonna do the weight painting based on that. So that it does like a fair bit of the work for you, a fair bit of the work that you would otherwise have had to do. And then you can just make whatever changes you want based on, if something is not how you expected it to be, you can like change it. And there's a couple of other more advanced things as well. Envelopes are a thing there, so you have to. I forgot what envelopes are. I had learned it a while back. I was just about to say you have to something, and then I forgot what you even do with them. So yeah, I'm gonna need to refresh my knowledge on it, just so I can set up a very basic rig, a very basic humanoid rig, and then I can use some model from. I can use any model. I can generate something in Vroid Studio, or I can download something from maybe the Godot asset library has a bunch of models. I can download one of those. I can use one of Kenny's models. Yeah, Kenny has a lot of. Shout out to Kenny, by the way. KENNEY.NL. That's their website. You can get a bunch of cool assets for game development purposes, and they're all licensed under Creative Commons, so you can use them for whatever you want. You can use them in whatever way you want. Okay, now, yeah, I can probably get a mesh from there, or I can just quickly sculpt an ugly looking ragdoll. That's not an issue. That's not going to be too much of an issue. I can even make something out of blocks. That's not a problem. The main objective there is not to make a good looking mesh. It's to make a rigged mesh, a properly rigged mesh that I can then export from Blender and bring into Godot, and then control that via script. That's another important thing, because what I want to be able to do is I want to be able to move the hand and have various bone constraints be respected. So I need to see if they carry over from Blender into Godot, or if I would have to set them up in Godot itself, which that's not a problem. I can set it up in Godot if need be. It's just that I don't know yet, so we're going to need to do research there. Okay, let's get back to this before I get too distracted again. Let me drink some water real quick, and then we can hopefully start. I was supposed to do this at my previous water break. Now I'm realizing I spent close to 20 minutes just talking about something else instead of diving into this. Give me a second. Okay. All right, so these are all the keywords. What all am I interested in here? Okay. Match, I'm guessing, is kind of like switch in C#. I think so. I think they've described a bunch of them like down. Okay, break, continue, pass, return. Class name. Okay. All right. Okay. I think static members, I did have a bit of confusion there. Actually, I can't remember if I had the confusion in, was it in GDScript or in Rust? I think it was in GDScript. Does Rust even have static? I don't remember. Anyways, let's test. I think I did. I think I did. I did a bit of static stuff here, and there were some rules to follow with static variables. Does that work? Expected statement found static instead. Is it only... Hold on, is it a case of like IntelliSense not having kicked in yet? Or is it something else? Okay, is it that static can only be used for methods? Because it says member variables, right? Okay, there's an ad playing, so I'm going to be quiet for 30 seconds. All right, welcome back. Okay, so it defines a static function or a static member variable. Okay, so do I define the static member variable here? All right. Okay, so was the issue that I was defining a static variable within an instanced function? Let me try that out. Hold on. Because I mean, that kind of makes sense. So this has init. So let's try to create static. Yeah, there it is. Expected statement found static method instead. Now let's put this here instead. Oh, indent. Okay. All right. So that was the mistake. Okay. Moving on. I still have to mess around with the debugging thing. Oh, I just realized my VTubing avatar is in the way. Where should I place it? I think resources. Just a second. Okay. All right, so I need to mess around with like debugging stuff in Godot as well. I haven't used a debugger in ages. Like, I'm not even kidding about that. I haven't used a debugger in ages. I got so used to doing that whole printing a statement thing. So it would either be console.writeline or debug.log or anything basically that prints a value onto out into the console window or into any kind of output area. I got used to that practice. So yeah, I need to look into that as well. I think we did mess around with enums previously. No, see, now I'm confusing. I'm kind of mixing up my knowledge of enums in GDScript and Rust, because I remember there was a nameless enum thing in Rust. Let's take a look at this in. I think it'll be explained here, right? I think enums do get explained. At some point they did go into it. Um, where was it? Oh, okay. It was in the example. No, it was here. It wasn't in, or was it in both Rust and here? Oh, I think it was here. Okay, so here we have the concept of nameless and named. Okay, all right. Then breakpoint, preload, preload a class or variable. Classes as resources. Okay, I need to look into that as well. That can be a useful concept later. Await, that'll be for kind of async stuff. Yield, assert. Asserts a condition, logs error on failure, ignored on non-debug builds. Okay. Then void, pi, tau, inf, and nan. Alright, cool. Operators. So this can be used for grouping. This is for subscription. Okay, yeah. I didn't know it's called subscription. But I do recognize this, like variable or whatever, collection name and index. Attribute reference, function call, okay, await, type checking, then power, okay. Then there's bitwise operations, identity negation. Hold on. What does this do exactly? Let me, okay, so we can get rid of a bunch of these things. Let's say a equals 5 and then plus a. Does that do something? This is an operator. This is an operator. So a equals plus a. Would that work? Oh, has a been defined already? What's the issue? Oh, wait, the issue was that I'm using Rust syntax. All right, so is this valid, or is there still an error here? I don't think there's an error here. Is there an error here? How do you clear this? I think this is the one, right? Okay, there's no error here. Now there's an error. Okay, I was just testing. Okay, cool. So let's print A right now and then print A again after this. So I'm going to run this. You guys won't be able to see the build, but that doesn't matter. You will be able to see the output over here. So let's see what it prints out. Okay, that didn't really change anything. Am I missing something here? Okay, let's try negation. Wait, negation as in flipping the bits? Is that what it's talking about? So it's kind of like inverting it? What would be a good example here? let's say I flip the bits of, actually, if I flip the bits of 1, it'll give me a whole different value, right? Okay. So then let's flip the bits of A. Or is it just making it like a negative value? Let's try this. Okay. A equals plus A. I'm missing something here. Let me Google this. I'm kind of confused about what exactly this is. Godot plus A. Or okay. Godot identity negation. I'm a tiny bit confused about what these two do exactly. Okay, we can move on. I can look at that later. Okay, then we have the usual arithmetic operators. Okay, then we have more bitwise stuff. Then we have comparison. Then we have inclusion checking. Inclusion checking in is also used with the for keyword as part of the syntax. Okay. Boolean not and its unrecommended alias. Its unrecommended alias. Why did they feel the need to specify that it's unrecommended? Is there some like issue there? Prefer the plain English version of Boolean operators as they are more accessible. Use and instead of this, use or instead of that, use not instead of that. You may also use parentheses around Boolean operators to clear any ambiguity. This can make long expressions easier to read. Oh, this is a good example. Yeah, this makes, well, I don't know if it's a good example. Probably because I'm used to reading the inaccessible way. Like, well, this. I'm used to reading this. Which is fine. I can still use like the words if that makes things easier. Okay, so we have more Boolean stuff. Then we have ternary operators. This, if, that, else, that. Okay. Typecasting. Okay. Assignment lowest priority. You cannot use an assignment operator inside an expression. Okay. Note the behavior of some operators may differ from what you expect. If both operands of the so and so are int, then integer division is performed instead of fractional. For example, 5 divided by 2 is equal to 2, not 2.5. Okay, so it gives you the integer version. It gives you the integer response. If this is not desired, then use at least one float. At least one float literal. Okay. The modulo operator is only available for what? For ints. For ints, for floats. No, it's only available for ints. For floats, use the fmod function. Okay, for negative values, the modulo operator and fmod use truncation instead of rounding towards negative infinity. This means that the remainder has a sign. If you need the remainder in a mathematical sense, use the postmod and fpostmod. Okay, I'm gonna look into this when I need to later on, not now. Okay, all right. Then we have literals. Oh, this is important because there are certain things that are Godot specific here that I need to look into. So, okay, we have the base 10, we have hex, we have binary. Good to know how to do all of those. We have float, we have regular strings, we have multi-line string. That's good to know. Let's test that out. Hold on. Okay, so let's. Does that work? Oh, okay. Uh, let's do this is, and then let's add the new line character. This is a sentence. So let's run this. Oh, look at that, dude. Yeah, it respects it respects new line as well. I'm guessing it respects tabs as well. Yeah, there it is. Okay, next, string name. This is an interesting concept. This and node path. I need to look into both of these. Um, this is shorthand for get node, node path. Oh, that's interesting. Get node, as in get any node. Oh, maybe it's get any child node. Yeah, maybe it's get any child node. So let's create a node here. This can be. Okay, let this be. I still need to look into window and sub viewport. I need to see what both of these things do. Is it possible that we can have like multiple windows spawning? Like that's kind of the idea that I'm getting, but like I don't know if that's how it works exactly. I need to look into it. Or could it be that Godot allows us to create our own like windowing system within the UI? That would be interesting. Wait, no, this is not one node, is it? This is a base class. But you can create a node out of it? Holy shit. Wait, what does this look like in the... Okay, so that's a window. Why am I not able to move this around? Okay, I'm missing some information here. Let's look into window real quick. Okay, window. Base class for all windows, dialogues, and pop-ups. A node that creates a window, the window can either be a native system window or embedded inside another window. All right, at runtime, windows will not close automatically when requested. You need to handle it manually using the close requested signal. All right. This can be interesting. I can I can do some interesting stuff with this. Okay, let's, just for the sake of, just out of curiosity, I'm going to run this and see. You can't see what's running because like the thing doesn't get captured, but okay, so what I'm seeing here is wait, does this okay, so I'm just going to describe it. What I'm seeing here is basically what you are able to see, like this little gray square kind of thing. This thing here that you see, this thing. I'm seeing this in the build, and it's a window that I'm able to grab and move around and resize and stuff like that. And well, there's an X button as well, but it doesn't close it. I'm guessing that's what the docs were mentioning, that it doesn't close it automatically. You have to handle that yourself. All right, cool. Good to know that this exists. Where was I? Here. Okay. 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 So I can look into this later on. For the time being, I need to get back to what I was doing here. So let's name this test node 01. I forgot what the shortcut was to switch to script view. Okay, control F3. I was confused between whether it's shift or control. Wait, it's been close to an hour. Is the music still going? I just realized that. Nope, music stopped. YouTube probably paused it. There it is. All right, cool. So, back to this. Oh, yeah, I was testing this out, right? So let's... Am I able to just... Oh, cool. Okay, so the path, it suggests a path here. How do I do something with this that's gonna show up in the hierarchy? Is there a get name thing? No. Get node. Well, that's gonna look for nodes, and no, that could get the node, right? Or does it expect? It expects an argument. Okay. What does dot mean exactly? Let me Google that. Godot get node dot. I remember reading there was some significant. You know what? It might be mentioned here, right? If I hold control, I think it shows. Yeah, there it is. So let's look at the docs. Okay, fetches a node. The node path can be either a relative path from the current node or an absolute path in the scene tree. If the path does not exist, null is returned and an error is logged. Attempts to access methods on the return value will result in an attempt to call so-and-so error. Okay. Wait. Fetching absolute paths only works when the node is inside the scene tree. When the node is inside the scene tree. Isn't every node technically inside a scene tree? Or cuz like I'm trying to visualize that. Cuz like okay, you have a node, right? This node tree, if I save this node as a scene, then that becomes a scene tree, right? Doesn't it? No. No, no. Wait, a scene tree is a tree of scenes. So like that's like multiple such scenes. But then see, I think I'm having that confusion again. Okay, so we have nodes. Nodes can be grouped together into a node tree. A node tree or a node can be saved as a scene, and then you have multiple scenes. Those scenes can be grouped into something else called a scene tree, right? But aren't those scenes technically also nodes? Like, how are they differentiating between them? Let's try this. Let's try this out. So we set up. Okay, node 2D is already a scene, right? So if I create a new scene, and then I add a node here, and then I add this. Can I wait? Can this be like its own? Oh, maybe there can only be one root, right? One what is it called? Scene root? Root node. There can only be one root node, right? But yeah, okay, so if I then make duplicates of this, isn't this considered a scene tree? If it is, isn't this also considered a node tree? I need to Google this, dude. I had looked into this a while back, and because I keep confusing between these things. Hold on. Godot node tree versus scene tree. Using scene tree, when a node is connected directly or indirectly to the root viewport, it becomes part of the scene tree. Using scene tree. Main loop. The way Godot works internally, root viewport. Oh, maybe I should read this. Yeah, maybe this is gonna help. Hold on. There's here scene tree. Oh, dude, I think I missed my hydration break. Yeah, I think I missed my hydration break, the last hydration break. So I'm gonna hydrate real quick. Anyways, we are close to the next hydration break anyways. So like, yeah, give me a second. Okay. Using scene tree. Introduction. In previous tutorials, everything revolved around the concept of nodes. Scenes are collections of nodes. Okay. They become active once they enter the scene tree. Okay, so this is where my confusion comes in. Real quick, let me just scan this page. Changing the current scene and so on. So, okay. Main loop. The way Godot works internally is as follows. There is the OS class, which is the only instance that runs at the beginning. Afterwards, all drivers, servers, scripting languages, scene system, etc. are loaded. When initializing is complete, OS needs to be supplied a main loop to run. Up to this point, all this is internals working. You can check main slash main.cpp file in the source code if you're ever interested to see how this works internally. Okay. The user program or game starts in the main loop. I'm glad that they wrote user program or game. Okay, this class has a few methods for initialization. No, this class has a few methods for initialization. Idle, fixed, and input. Again, this is low level, and when making games in Godot, writing your own main loop seldom makes sense. Okay, alright. SceneTree. One of the best ways to explain how Godot works is that it's a high-level game engine over a low-level middleware. The scene system is the game engine, while the OS and servers are the low-level API. Let me open up this class real quick. What does this say? Provides access to common operating system functionalities. Wait, really? Alert, close, crash, create instance, create process. Okay, so at some point I should look into this as well, because this is kind of interesting. But yeah, okay, what's the description here? Provides access to common operating system functionalities. This class wraps the most common functionalities for communicating with the host operating system, such as video driver, delays, environment variables, execution of binaries, command line, etc. In Godot 4, OS functions related to window management were moved to the display server singleton. Good to know. Also, it's kind of cool that we have like direct access to certain OS related features. Because like on, let's say on the Unity side, for example, unless the game engine itself provided those features, you would have to do it through C#, through like the .NET, whatever .NET provides you with. Which, I mean, it's not like .NET is limited in that aspect, but like certain things you would end up having to, certain things that were like super OS specific or that were like super OS level, you would have to then use pinvoke for them. To be fair, that could also be the case here, where, because it does say that it provides the common operating system functionalities. So like that, there's going to be a limit to that as well, right? Like what it's able to do. But for example, window management related stuff, I don't think it provided anything for that. I don't think like Unity or C# provided anything for that. I don't remember on the C# side. Because like on the C# side, if you're working with like wind farms or something, then maybe there's some window management stuff. But like on the Unity side, no. I'm trying to remember if I ever saw anything like that on the Unity side. I don't even think you're able to create windows in the UI there. Like you have to create your own concept of windows there. You have the other elements, and like they give you the tools to build that kind of concept if you want. Uh, but yeah, that's kind of interesting. Excuse the silence. I'm just trying to remember. And okay, anyways. All right, so yeah, carrying on. Where was I here? The scene system is the game engine, while the OS and servers are the low-level API. The scene system provides its own main loop to OS. The scene system provides its own main loop to OS. SceneTree. Okay. This is automatically instanced and set when running a scene. No need to do any extra work. It's important to know that this class exists because it has a few important uses. It contains the root viewport, to which a scene is added as a child when it's first opened to become part of the scene tree. Oh, sorry, I zoned out for a second there. Okay. It contains the root viewport to which a scene is added as a child when it's first opened to become part of the scene tree. More on that next. It contains oh wow, okay. Alright. Alright, it contains information about the groups and has the means to call all nodes in a group and or get a list of them. It also contains some global state functionality, such as setting pause mode or quitting the process. Okay, when a node is part of the scene tree, the scene tree singleton can be obtained by calling node.getTree. Okay, let's try that. What does this return? Okay, so getTree.getNode, get nodes in group, get first node in group. No, okay, this is first node in group. Is there just like a first node? No. All right, let's try to get a node count. Wait, what just happened? Oh, I haven't saved this yet. Okay. Let's save this as some node, some underscore node 01. You know what's interesting here? So this scene is called some underscore node 01, right? But the root node that I'm assuming is what I was saving. Or, I mean, my assumption might have been wrong. But like, my mind was connecting the scene to this node. But this thing gets saved as a scene, and then you can drag and drop it into into another scene, right? But like the root node itself, it can have whatever name. Like they don't have to share the same name. That's kind of interesting to me because my mind was connecting. It was connecting this scene to the root node within the scene. So like, I still have to kind of like understand. I guess I still haven't fully connected the dots when it comes to node tree, scene tree, and how they work together. Okay, I also need to look into Viewport. Abstract base class for viewports encapsulates drawing and interaction with a game world. A viewport creates a different view into the screen. And a viewport creates a different view into the screen or a subview inside another viewport. Oh, that's interesting. So would we, for example, be able to use this to do something like picture in picture? Or something like how, for example, if this, like when we use render textures to be able to visualize what a camera in the scene somewhere else is seeing. Children 2D nodes will display on it, and children camera 3D nodes will render onto it. Okay. Yeah, so I think my guess was right. Like it's something similar to that. Optionally, a viewport can have its own 2D or 3D world, so it doesn't share what it draws with other viewports. Dude, okay, I need to look into the concept of viewports. I need to learn more about viewports. Wait, this is the scripting reference. What about like just viewport? Wait, hold on. There was some. Oh, here it is. Okay, these are links. I thought these were leading to like lower down in this same page, but no, it's leading us to a proper tutorial. Think of a viewport as a screen onto which the game is projected. In order to see the game, we need to have a surface on which to draw it, and that surface is the root viewport. Viewports can also be added to the scene so that there are multiple surfaces to draw on. When we draw to a viewport, this is not the root. We will call it a render target. We can access the contents of a render target by accessing its corresponding texture. By using a viewport as a render target, we can either render multiple scenes simultaneously, or we can render to a texture which is applied to an object in the scene, for example, a dynamic skybox. Viewports have a variety of use cases, including rendering 3D objects within a 2D scene, rendering 2D elements in a 3D game, rendering dynamic textures, generating procedural textures at runtime, rendering multiple cameras in the same scene. Dude, this is kind of cool. Like the fact that we have this option. I can already think of various things that I can do with this. And it seems like it's I don't know if extendable is the right word. But like it seems like there's a lot of stuff that you can do with this. Okay, so I'm going to need to read up on this. For now, let's carry on reading about SceneTree. When a node is part of the SceneTree, the SceneTree singleton can be obtained by calling so-and-so. Okay. Root viewport. The root viewport is always at the top of the scene. From a node, it can be obtained in two different ways. The root viewport is... I'm trying to make sense out of this. Hold on. The root viewport is always at the top of the scene. From a node, it can be obtained in two different ways. Okay. This node contains the main viewport. Okay, so I just use getTree.root. What happens if I print this out? What am I gonna get there? Oh, I just realized I don't think I ran this code. Actually, did I run this code? I don't think I ran this code. Also, even if I did run this, it wouldn't... Even if I like ran this scene that I currently have open, it wouldn't run this code. That's because this code is part of the node 2D node. Or this GDScript is attached to the node 2D. Wait, no, it would run it then, right? Oh yeah, no, it would run it. In fact, it would run it quite a few times. Yeah, it would run it quite a few times. Okay, I can disable, or I can, well, delete all of these. Yeah, let's run this. Okay, so this counts 4 nodes. That's kind of interesting. What all is being counted here? Returns the number of nodes in this scene tree. So this scene tree, I'm assuming it reads the child nodes as well, not just the parent nodes. So not like the scene tree's immediate children. Wait, I need to be able to visualize this because we just got an extra sort of layer here. So how this works is you have the scene tree. Wait, okay, so OS is wait, okay, hold on, dude. One of the ways to explain how Godot works is that it's a high-level game engine over a low-level middleware. The scene system is the game engine, while the OS and servers are the low-level API. The scene system provides its own main loop to the OS, which is called SceneTree. Okay, this is automatically instanced and set when running a scene. No need to do any extra work. Okay, so the scene tree contains a viewport. All right. No, hold on. It contains... It's important to know that this class exists because it has a few important uses. It contains the root viewport. The scene tree contains a root viewport to which a scene is added as a child when it's first opened to become part of the scene tree. Okay, so we have the scene tree, and then we have the root viewport. And then as part of that root viewport, we have other scenes. Did I get that right? I'm not sure if I got that right. Hold on. Let's go back to Godot. So we have some, I call this some node 01. This is a scene. I've opened up the scene. Within this scene, I have a node. Hold on. So we are calling this a scene, right? This scene. Let's not talk about this scene. Let's talk about this scene. Node underscore 2D scene. So this is a scene right here. Right, this is a scene. This scene contains this root node and this test node. This gets added to this scene. Right, but this scene is currently part of the root viewport, which is part of the scene tree. So what exactly is going on here? When we open up any scene, let's say I opened up this scene, because now that I'm here, is it that there's a separate scene tree here? Or is it just one scene tree? I think it's one scene tree, right? So that's the main loop. This is automatically instanced when running a scene. Wait, this is automatically instanced when running a scene. So every scene then has its own... Every scene then has its own scene tree, right? Any scene that you open, when you open it, there's a scene tree. That scene tree has a root view node. Is that what it's called? Viewport, root viewport node. And then that viewport node has the scene that you just tried to open, which would be nodes and, you know, it would be the root node of that scene and any child nodes as well. Holy shit, dude. Okay, let's carry on reading. Maybe then I'll be able to connect the dots better. Okay, this node contains the main viewport. Anything that is a child of the viewport is drawn inside of it by default. Okay. So the viewport and the scene tree don't get visualized here. So we just assume that they are part of whatever we are seeing here is part of a viewport. It's part of a root viewport. And that root viewport is part of a scene tree. Okay. Oh, wait a minute. Wait. No. Okay, what if I run this here? What if I run it from this scene? Now it says 3. Alright, so I'm trying to understand. It says 3, right? This scene only has node 2D. So previously I was doing it here in some underscore node 01, which has node 2D and, well, node 2D, but like this node 2D is a scene, and this actually has other child, it has a child node. But like because it's a scene, so it's kind of like collapsed. It's not. It's sort of I forgot what they call it. But like they don't show the child nodes and stuff, so it gets treated as like a single node. That's probably why I was showing 4. Now over here it's showing 3. So I'm wondering if that third node that we are not seeing here is the viewport node, the root viewport node. Okay, let's carry on reading. Where was I? Okay, this node contains the main viewport. Anything that is a child of a viewport is drawn inside of it by default, so it makes sense that the top of all nodes is always a node of this type, otherwise nothing would be seen. Yeah, that makes sense. Yeah. While other viewports can be created in the scene for split screen effects and such, this is the only one that is never created by the user. It's automatically created inside the scene tree. Okay. All right. So this is a node. So am I right to think, is there a way that we can enumerate all of the nodes in like through get tree? Hold on. Wait, what does get tree return exactly? What is it returning? It returns a scene tree. Okay, let me look up the scene tree. Like, what properties does scene tree have? Oh, there's a get viewport function. Is that gonna have access to any of the, hold on, get tree? Wait, can I directly get the viewport? Get viewport. Okay. Does that take any parameters? I don't think it does it? No, it doesn't. Okay. So that's going to return the viewport. Now, do I have access to any, like, am I able to get, like, the child nodes if... So, like, can I just do get node here? But that's dot. What is that going to return exactly? Okay, let's try printing this. I don't know what it's returning. Is it gonna give me the information of the node if I just try to like print out the node? Oh, the information is, yeah, it gives the information. So that's the root node. That is this, I'm assuming. Node 2D, that's the root node. So then I could get a child of that, right? Oh, I could directly use get child. No, then I have to give it an index, wouldn't I? Yeah, I have to give. Well, I know the index, right? What's that next parameter? The next argument? I can't see that. Hold on. Include internal. Okay, yeah. Let's just get this. So if I'm right, it should be test node. Well, it's not giving me the name. It does say test. It does say node 2D. Oh, wait, no, I need the name. I need the name because I need to know. How do I get the type? Okay, let's Google this. Godot get node type. How do I check a node's type? If you need to check the type of a node, you can say, actually, get node name. How to get the name of a node of instanced scene. There's something called get base name. Okay, let's try that on the child node. Okay, and then get... No, there's no get base name here. Does this work? Okay, let's try. Oh, there is an issue. Invalid call, non-existent function. Oh, okay. Wait, this got... Why does this say... Why does this say some node 2D? I haven't named either of these some node 2D. I have named this one, but this is some underscore node 01. Where exactly did this come from? Oh, is it inheriting from... Oh, it's because I called it... Oh, okay. That's where it's getting its name from. Alright. That's fine. That is okay. I can close this. Where was I? Here. So this doesn't work. Let's try another solution. Okay, there's an ad playing, so I'm gonna be quiet for some time and, well, 30 seconds. And I guess I'll hydrate in the meantime because it's also hydration time. All right, welcome back. Um, I'm trying to figure out. Okay, do we have anything here that can get... Okay, so do we have get instance? Get scene instance? No. Okay. Um, what about just instance? Or... Nope. Am I Googling something wrong here? Like, why is it so hard to find this information? How do I get the name of the node that I'm touching? I think I might be Googling wrong here. Or maybe I just haven't found the... Okay, there's a get name method. No, there's no get name method. That was in the question. Dot get collider dot get name. How do I get the base name of a node? Okay. Finding node by name. Better way to get node name on collide. No, these people are talking about collision. And maybe the collider does provide something for that, but like I'm not in a collision situation here. Uh, every node needs to have a unique name, and you can't reliably get the information of what the original name is because the node doesn't store it. What exactly are you trying to do? It's likely groups are better suited for the job. Maybe you should look in. Okay. All right. Um, as an al as an alternative, no, an alternative is exporting a node path. So, oh, can I get the node path? Wait, what exactly does this print? Am I able to? Oh, I think that's a type. Okay, never mind. Yeah, so what I was wondering was, okay, can we do something like, okay, so get tree, um, that's gonna give us the scene tree, right? And then we do get viewport, I guess. No, there's no. Oh, is viewport like a direct? Okay, get viewport dot. Okay, but what if I want to access it from the tree, from the scene tree? So here we have get. No, we just have get node count. So the scene tree contains the viewport. The viewport contains the things under them. So if I wanted to access, if I wanted to like read the scenes and like the nodes and stuff under it, I would need to access the viewport, right? Now, how do I access the viewport from the scene tree? I mean, I'm getting the current scene tree anyways, right? The current root scene tree. I'm assuming get viewport gives me the current root scene tree. Isn't that what the doc said? Returns the node's viewport. So I'm assuming this is going to be the root viewport because I haven't created any extra viewports here. Okay, so we get the viewport and then wait, there's a has node function. Has node. Um, node 2D, I guess. So let's print this out. Okay, so what if I added a 1 here? Would that still say true? No, it doesn't. Okay, so it's getting the right node. Oh, okay, so that clarifies it. So get viewport, which is our root viewport. It has I forgot why I was even trying to do this, but like, okay, cool. Um, I forgot what led us to this, like what doubt of mine led us to this. But yeah, I'm kind of starting to visualize the thing. So you have the scene tree. The scene tree has the root viewport, and the scene tree. We can't see them because it has been mentioned here, I believe. While other viewports can be created in the scene, this is the only viewport that is never created by the user. It is automatically created inside the scene tree. So you cannot see the scene tree, you cannot see the viewport. Also, the viewport is a node, apparently. I think so. Um, so the viewport has all the nodes that the scene contains. And what the scene contains is a bunch of nodes. Right? The scene contains its own root node And then that root node contains a bunch of other nodes, like it has other child nodes. Now, what is the scene here exactly? Like, what role is the scene playing? Because scene at this point, it just seems like, first of all, it seems like just a concept there, and it also seems like a resource, an asset. But like within the context of these bunch of nodes, I'm having a hard time figuring out where scene fits in here. Because like, okay, we have some node O1. Actually, this is becoming confusing. So what I'm going to do is I'm going to change this to uh okay, I'll change this to some underscore node O1, right? And I'll close this and I'll delete this scene, and then I'll rename this. So some node O1 scene. I'm gonna add the name scene here just so I have that you know. Just a second. What did I just change? Oh shit! I changed the script. I meant to change this. So let's copy that. Come here. Change this. That's done. Okay. And this can just be called now some. Okay. Wait. Did something extra get added here just now? What is this? Oh, damn. Okay. A second thing got added. So we are gonna close this and delete this. Is the reference still maintained? Wait, the following files are newer on disk. All right, reload. The class name so-and-so hides a global script class. Okay, I broke something here. What's the issue? Okay, let's take it back to some node 2D. All right, I guess there's no issue. I think a problem. I think a problem occurred was. I think a problem occurred because I don't know what exactly I did here. I don't remember what exactly I did here that caused a new GDScript to be created. Or maybe there was another GDScript. I just didn't realize what I was changing, and yeah. Okay. Um. So where was I? Now that we have done this, let's create a new scene. Um. I'll name this some node O2. Okay, this can have its own child node, which can be a node 2D. Great. And now I'll save this as some node. Oh, I should have used their naming convention. Anyways, some underscore node 2D. No, some underscore node O2 scene. Okay. Just a second. Oh, also, hydration break. Give me a second. Okay. So why was I doing this exactly? So we have this here. Yeah, I think I was trying to understand how exactly does the concept of a scene fit in here? What exactly is a scene? Because like I've saved some underscore node O1 scene. I've saved that as a resource, right? That resource is a scene. I can drag and drop that scene into another scene, or rather, I can drag and drop that scene. I can make that scene a child of another root node in another scene. I'm trying to understand at what point is it considered a scene and at what point is it considered a node? Is it that we are calling this a scene from the point of view that okay, we are able to open this up? This scene is a container. This scene is a resource representing this root node and whatever child nodes the root node may have. Like, is that what's going on here? And then can this scene, which is a container, this can be used. This can be added as a child node to other root nodes, but there it would be considered a node, not a scene. I just lost track of what I was saying. Um, yeah, I need to read up on this more. Cause like, okay, we have the scene tree. The scene tree has the viewport node. The viewport node has the root node, and that root node has a bunch of child nodes, right? Where does the scene fit in here exactly? Because let's say I have this, right? This what we are calling a scene here. This scene is representing the root node and its child node, right? It is representing this group of nodes. The scene is representing that, right? Are we calling this a scene just so that we have some kind of structure? Are we calling this a scene just so we have the concept of some kind of container that the nodes can be stored into? Because like when we open up a scene, it's isn't it loading up a new scene tree? And then that scene tree has oh, okay, so here's another question. This is a scene. Does the scene just have this root node and the child node, or does this scene have its own scene tree, and that scene tree has the viewport node, and that viewport node has this root node with the test node. How is this hierarchy working, dude? Hold on. Let me carry on reading. Okay, SceneTree. When a node is um hello, hold on. Let me read that name. Hello, Volmancer. Welcome to the stream. Okay, so you said everything is a node. A stack of nodes is called a tree, and a tree, example, a construction of your sprite, rigid body, etc., would be a character scene. Okay, because the character is a node in a tree, it can be added to other trees or other scenes. I'm really trying to visualize this. Okay, let me read that again. Okay, everything is a node. Wait, I'm fairly new to Godot too, and as a longtime Unity dev, I've been struggling to adapt to this. Yeah, I'm trying to like I get the concept that everything is a node, and you can save a node as a scene. After you save it as a scene, you can then add that scene as a child node to another root node. So you can then basically use that scene in other scenes. But at what point is it considered a scene and at what point is it considered a node? Also, I'm reading here about like the scene tree, right? The scene tree has a viewport node, a root viewport node, and the viewport node has does the viewport node have the scene that you are trying to load, or does the scene you are trying to load have the scene tree that has the viewport node and then the root node that's within your scene apparently? Like I'm still okay, I need to oh wait, there's something here explaining something more about it. I think I'll okay, hold on. Let's carry on. Let's carry on reading. Um Scene tree. When a node is connected directly or indirectly to the root viewport, it becomes part of the scene tree. That makes sense. This means that, as explained in previous tutorials, it will get the enter tree and ready callbacks. Okay. Root. Okay. Okay. When nodes enter the scene tree, they become active. They get access to everything they need to process, get input, display 2D and 3D visuals, receive and send notifications, play sounds, etc. When they are removed from the scene tree, they lose these abilities. Okay, tree order. Most node operations in Godot, such as drawing 2D, processing, or getting notifications, are done in tree order or top to bottom. For example, the top node in a scene has its ready function. Hold on. This is not going into the becoming active by entering the scene tree. Okay. A scene is loaded from disk or created by scripting. The root node of the scene is added as either a child of the root viewport. Wait, the root node of that scene is added as either the root node of that scene. So there's only one root. Okay. Is added as either a child of the root viewport from scene tree or to any of its descendants. The root node of that scene. Okay, so this it's slowly starting to answer my question about like what exactly is a scene. Was the concept of scenes just created so that we have a container that we can save to the disk, that we can create into we can turn into a resource that can then be reused? um it's kind of seeming like that, because okay, the root node of that scene, right? The scene at this point is a resource. It's a container containing the root node and whatever, if any, child nodes the root node may contain, right? That kind of also explains why we are able to have a separate name for the scene and the root node. The root node and the scene don't have to have the exact same name. Okay, so what happens next? Every node of the newly added scene will receive the. Just a second. Is the music still going? Every 1 hour I remember to check the music. No, it's not. It's not still going. So let me just. By the way, speaking of music, shout out to Machine Supremacy. Go check them out. Um, Pretty awesome band. Pretty awesome music. If you like, video game inspired music, you you'll you'll you should check them out. What was I doing? Yeah, okay, back to this. So every node of the newly added scene will receive the enter tree notification callback in GDScript in top to bottom order. An extra notification ready is provided for convenience. When a node and all of its children are inside the active scene. Wait, no, what? An extra notification ready is provided for convenience when a node and all its children are inside the active scene. When a scene is removed, they receive the exit scene notification callback in GDScript in bottom to top order. Okay, so this was meant for something, this was being explained for something else, but it kind of helped me. A scene is loaded from disk or created by scripting. The root node of that scene is added as either a child of the root viewport. Now this brings me back to, is there only one scene tree ever? Or are there multiple scene trees? Okay, so I need to do a fair bit of research on this. Before I proceed with this, I need to do quite a bit of research to understand exactly, like, I need to understand exactly how scene tree, viewport node, scene, and node, how they work with each other, and which one is inside the other. Because so far, I know that a root viewport is inside a scene tree, right? And the root viewport, when you load a scene, the root node from that scene gets loaded into the root viewport. But does that mean that there's only ever one scene tree and only ever one root viewport? Or is it that every scene that you load has its own scene tree and its own root viewport? And because, like, if that's the case, if every scene has its own scene tree and root viewport, dude, I need to Google this. I need to Google more. It's also getting to be close to 2 hours. I need to go do something else as well. So I'm gonna end the stream here. I'm gonna carry on doing my research. Voimancer, thanks for stopping by. And oh, thank you for the follow as well. Appreciate it. Yeah, I'm gonna end the stream here. I will hopefully stream again tomorrow, probably doing more Godot stuff because now I've got a lot of Googling to do here. Have fun with Godot. Have a good day. You too. Yeah, that's gonna be it. I hope you guys have a nice day, and I will see you all next time. Peace.